For those of you who have seen it, so this was a big thing for me. I was in Italy. I've never been kind of almost ever outside of Italy, and I was accepted in a university in France. I went, I passed my exams. I was happy to pass the exams, and I wanted to see the Eiffel Tower. So welcome to all the YouTube live streaming. It seems it works here, and we may have also some friends and family from Italy too on this YouTube live. So welcome to all of them. How many are they? You don't know right now. Okay, fine. So whatever the number is. So welcome to everybody. So we're talking about Irat Hashem. Irat Hashem, fear of Hashem, is the real wisdom. So I want to give a personal example of what I think Ira means. So I went from Italy to France, and I went to see La Tour de Monsieur Gustave Eiffel. And this is the Tour Eiffel. It doesn't look like, okay, when you look on the pictures, it's fine, it's nice and fancy. When you are there under, you see this gigantic thing. You know, and this is the best picture I could find, but it doesn't reflect what I want to say. You are there, you are, what, in awe, and what, this is amazing. In fact, if you study engineering and you know how the forces are distributed in the Eiffel Tower, it's a feat of engineering. And by the way, it was built for the Exposition Universelle of 1889, supposed to be destroyed a few years later, and the Parisians of course didn't want to separate from that, so it remained up to these days, and it's a feat that it remains. It's a metal structure, iron corrodes, so they have to paint it all the time, they have to check it all the time, but it's still there. So I suggest you go and see it before, whatever. Anyway, so this is and this is the engineering thing. And it was the first tower at the time that surpassed the 300 meters. Interesting thing. Another example of this feeling was this. And many of you from New York probably know this bridge, the White Stone Bridge. Okay, fine. They have in America, they have tons of this bridge. But imagine, this is now a European guy. At this point, I was only between Italy and France, never been to the States. First time in the States, they gave me a car with automatic transmission. And in Italy, there was no automatic transmission. So I go there, and I said, excuse me, how does this work? And they say, just put it on D and drive. Okay, thank you. Okay, so I put the thing on D, and of course, you are used with 2 feet. With cars with manual clutch, for those who have ever driven this thing. So when you do this, I started pushing the brake with the left. And I was there, like this. And then I go and I got completely lost. There was no Waze at the time. We're talking here about early 1990s. And so I get into this White Stone Bridge. And this White Stone Bridge, when you look at this, it's like this. You are here in the car, and you see this monster thing like this. I was there in the middle lane, probably going 20 miles an hour, people honking and passing from all over the place. I was there, what's this, right? So this is the feeling that I think sometimes we should have when we look at things from a scientific perspective, and that's the goal today. So just for this, a last kind of introduction from an amazing sefer. This is Chovot HaLevavot, and Rabbi Victor Miller has a Perush on it in English, which is absolutely amazing. But he says something beautiful. He says, the most direct way to obtain a clear understanding of Hashem's presence is by examining the wisdom that is apparent in His creations. So to understand Hashem, you have, I think from my understanding, 2 ways. Learn Torah 24/7. That's one way. The other one is start looking around and look at the world and say, wow, this is amazing and heavy. And that's what we're going to try to do today together. So the study of creation is the highway to Yirat Hashem, which was the wisdom, right? So that's what we want. Let's try. So now I want to introduce to a quote that, to a thinking and a quote that are amazing. Only the French-speaking people may know who this person is, Rav Yosef Chaim Sitruk Zatzal. Anybody heard about him? Okay. So those who didn't, I have a mission for you. You go and learn French. Once you learn French, I'm going to give you shiurim of him, and this is the best thing you have ever heard in your life. It was absolutely, he turned around Jewish Yiddishkeit in France in the 21 years he was chief rabbi in France. It was something unbelievable. France was a huge Makom Torah, times of Rashi, Tosafot, Provence, and so on. After that, it was the Midbar, nothing. And then they started, Rav Yitzhak Salanter came there and planted the seed. There were a few things, but the one who really made it sprout was Rabbi Sitruk. And today, you have a bunch of people that made Aliyah from France, and ask any of them, and they will tell you about him. So anyway, he said something beautiful. In one of his tapes, he talks about the miracles, and he says, when you talk a miracle in Hebrew, nes, pele, or mofet, those are terms that denote extraordinary phenomena above nature, beyond the laws of nature, right? If I dropped this thing and it started flying, that would be above the laws of nature. That would be a miracle. However, he said, the Chachamim wanted to give a semblance of rationality to the miracle. How did they do it? In Pirkei Avot, you know that one Pirkei Avot says there are 10 things that were created on Ben Hashmashot the twilight, and they were the rainbow, the man, the mouth of the earth, the mouth of the donkey of Bilam, the tablets, the letters, etc. Some 10 things that were created in there. Those 10 things are absolutely miraculous, but the Torah says they were created, so it's not a miracle. They were already created, right, so to speak. And the Maharal says, Hashem wanted the creation to be rational, with clear laws, and that Hashem respects these laws. So he fixed the laws and he respects the laws. So no exception here. He does not want to change these laws of nature to respect the freedom of man. So that's what the world we have. And in fact, Rav Sitzvik there's a quote that is so nice. I apologize for those who don't speak French, but I had to put it in French, because in French is pure poetry. For those who understand French, because I know some people from Italy understand, nature, c'est le voile pudique de protection que Dieu étend sur l'homme pour ne pas le forcer à croire en Dieu. What does that mean in English for us? Nature, the modest veil of protection that God extends over man so as not to force him to believe in God. Remember this sentence. We're going to see it at the end. So what is nature? Nature is a protection that Hashem puts on the world to give you an option, to give us an option, a bechira, not to believe in him. Unbelievable, right? And we're going to see, when we see this after in an hour or so, we're going to see this quote again, and you read this quote with a completely different understanding, I hope. So who was the greatest scientist of all time? Let's take a poll. Tell me some names. Who was the greatest scientist of all time? Right? Einstein, Newton, Italian Leonardo da Vinci, right? I know some may disagree, but I think that Rav Victor Miller was the greatest scientist of all times. Because if the definition, in fact, interestingly enough, if any of you have seen his booklets this last week, I think it was Mamash Mina Shamayim, it's called The True Science. It's called True Science. And he said that all the scientists are shakranim. They're all liars. So be careful about believing what I'm saying. So anyway, he said Rav Victor Miller had this knack for looking at nature, and he was not, I'm not saying that he knew equations or relativity better than Einstein, but he could see something in nature and see the big picture of what that meant and what was behind. And I'm going to give you an example now. He has amazing books that I strongly, these are in English, you don't need to learn French for this, okay? So Rejoice, O Youth is an amazing book where you have a discussion between the Chacham and the person who asks questions. And he touches on everything, and the science part is absolutely beautiful. By the way, an anecdote I heard about him was someone came to Rav Victor Miller asking a scientific question. So he said, I need to go in my office and check. He came back, and the guy starts talking, and then he has a second question. He says, so I need to go back to the office and check for you. So he goes back. And then he comes back, they start talking, and he has a third question of science. And Rav Victor Miller says, I'm sorry, I cannot go to the restroom a third time. So that's where, I mean, this is where this man was learning science. Because this man, someone said, I don't agree with everything that Rav Miller said, but how can you argue with someone who learned Shas 100 times? So anyway, unbelievable. And this is a shorter version called The Universe Testifies More on the Science. He has a quote in your Joshua Youth that I had to put in here. This is new, you haven't seen it 2 years ago. Truth is everywhere, but few men are able to see it. And this is something that I would like that we see together today. The truth on a very small example. Okay, so his recipe to acquire wisdom is you look carefully at something and you think about it. You meditate on it. And you observe more carefully and you think some more. And you repeat this cycle many times. And you look and you ask questions. and eventually you be in awe of Hashem. That's somehow his recipe. Let's do an example. The colors are really off here. Okay, fine. Anyway, so this is an orange. Let's see, I'm kind of trying to play Rabbi Victor Miller, but more with the scientific tack. What? Okay, can't you unzoom it? Okay. This is an orange. Let's try to see an orange and study it from a technical engineering perspective. You have a feeding connection with time control release mechanism. This thing is very strong, and at some point, it just becomes weak and it goes down. And by the way, from this little connection, all the nutrients, all the inside and outside of the orange, all the molecules that have to come in, come from this little connection here, right? It's a pure miracle. The inside of the orange is different than the outside. We'll see more later. And then there is a first level of cover, the peel. And the peel is sunproof, waterproof. It's type control color, because when it's mature, it becomes orange. But before it's green, so you confuse it with the leaf. So it tells you, I'm not ready, don't pick me up. Inside, the peel is white because you don't need the color. So we're not wasting any effort in coloring the inside. It has a nice smell. It repels also, it says also, it is also antimicrobial. It repels the insects. It's amazing, amazing engineering of the peel. You can stay there and do a Ph.D. on it if you want. Then flavor presenting, and then inside of this packaging, you have what they call the carpel. The carpel is this thing here. There are something like 8 in an orange or something like this. And basically, it's a package thing with the flavor inside. But it's not the last kind of package. You have a third level package, because if you look more carefully inside the carpel, you see that there are little pockets that are kind of millimeter level size, right? Yeah? Rav Shafir, Ben Zion Shafir calls it bursts of flavors. You have inside a bunch of bursts of flavors inside. And then you have the seed. The seed contains all the information to form a new tree and to produce hundreds of oranges. It's amazing. As Rav Victor Miller says, you get a coupon for another bunch of oranges, right? And if you think about this, the seed is white. It doesn't want to entice you. It's slippery, it wants to be spit up, and it's bitter. So if by mistake you eat the seed, you don't want to keep it in your mouth or to swallow, you just spit it up. And that's exactly what should be. It goes in the ground to grow new oranges. So this is one example of how when you look at something obvious, like an orange, you can stay there and we just scratch the surface. But at least with this, you see that there's a little more. We're going to see more detail about the orange today. And of course, as a scientist, we need to talk about the scientific method. In short, the scientific method, you make a hypothesis, and then you test it, and if it's valid, it's a valid hypothesis. The point, Richard Feynman was the Nobel Prize of Physics, Jewish Nobel Prize of Physics, amazing, amazing physicist. If you like physics, he has the Feynman lectures on physics are one of the best physics books ever. And there are his lectures on the web, by the way, if you also want. But what he said on this, he says, every theory is only valid until someone proves it's not valid. So we never have a valid theory. It's just because someone has not proved invalid that it still holds, right? And sometimes you find out it doesn't hold, and then you are back to the hypothesis. So you need to re-examine if the hypothesis is right or wrong. Now, to do science, there are two ways, and I like this very much. There is the Lieutenant Colombo way of science and the Agatha Christie way of science. So I loved Lieutenant Colombo. If some of you have seen his series, you remember that the film always starts with the murder scene. You see from the beginning, you know exactly who's the murderer, how he killed, etc. You see the whole thing. You say, hold on a second, why do I waste time watching a video where I know everything? No, because then you see how he investigates and he questions and the intelligence and the piqueur, he goes and he finds out who the murderer was, right? And this is one type of science. You see something, Newton is sitting under the tree, the apple falls on here, gravity, and then he starts investigating and thinking, maybe force equals product of the mass over the distance square and things like this, and then comes up, right? Or, right? So this is, a lot of science is done the Lieutenant Colombo way. Today, a lot also is done the Agatha Christie way. The Agatha Christie way, I don't think I ever read a book of hers by her, but I think I understand that basically you have a murder, You don't know nothing about who killed. There are 5 suspects. You go through 300 pages of a book to just discover in the last 2 pages who of the 5 was the real murderer, right? So, and let's give examples in science. X-rays, Röntgen. Here in Israel, it's interesting. They don't call it X-rays, they call it Röntgen, right? Name of the inventor, William Conrad Röntgen. He discovered this by chance. He was playing with high voltage gases and he saw a strange radiation. And then he called his wife. He said, can you put your hand in there and you see her bones? You know, this lady had on her hand lifetime dose of radiation from X-rays in 1 second. And people didn't know, and it became very interesting because you could see through people, through that. So in France, they liked it very much, right? But anyway, so the X-rays, the problem of the X-rays is they figured out that it works, but they didn't know much about it. They didn't know it was an ionizing radiation, that it was very dangerous. And the first scientists, unfortunately, that worked on X-rays had lost their hands because they were playing with X-rays, and they ended up, they didn't know that they were damaging themselves because the X-rays are dangerous. You can only do it and use it a little bit, okay? Agatha Christie model is, for example, today there is a lot of computer modeling of things. I have some colleagues, some very smart colleagues that work in using computer models to predict properties of new materials for batteries, for example, or for other things. So with the computer modeling, you don't know what the final answer, but you say, I want to find the material that has those kinds of properties, and you start playing with all quantum mechanics equations, and you do models, etc. And the computer power today is unbelievable, so there are gazillion calculations done in the background. You come after a week and you find some answers, and then you have to test it. Because the computer model is telling you this material will be very good for a battery, but you don't know if it's true or not. You need to go and then contact the experimentalist to try to see it. So those are 2 of the ways that we do science. Today, we're going to do science the Lieutenant Colombo way, okay? So we're doing science on something that Rav Dessler, that's amazing. Strive for Truth, if you haven't read that book, that was one of the first books I read, kind of doing tshuva between Rav Sitruk and Rav Dessler. The books have a thought, the thinking that is in the Michtav Meliyahu is absolutely unbelievable. Unbelievable. And he says something beautiful. I want to show you 2 quotes. He says the following. He says, we're going to talk about the seed today. And he says, the only difference, he says, imagine that you could see Tchiat HaMetim. You put a dead person on the fire, and then suddenly you see bones coming out, you see the flesh coming in, and you see the person being recomposed and so on. If you saw this, what would you call it? A miracle. It's a miracle, right? But you plant the seed of an orange, and then you come back and you find an orange tree, and orange is growing, and you don't say it's a miracle. It's just nature. It's just normal, right? It's just pashut. He says that the only difference is that we are used to the resurrection of seeds, but we are not used to the resurrection of people. But you never thought it this way, right? Resurrection of the seed. We're going to see. The seed, by the way, if a seed is a dead thing, somehow. We're going to talk about that. And he has another thing. He says, this is amazing. This is Rav Dessler at his essence. He says, if the situation were reversed, meaning we are used to see dead people coming out of the grave, but we never saw an orange growing from a seed, we would call the resurrection of bodies nature and the resurrection of seeds miracle. Right? It's amazing. So he's basically saying, because at the end of the day, like the Rambam says, everything is a miracle. Chokhmah she'en lo ketz. There is no end to the chokhmah in what we call nature. But nature has been used, unfortunately, especially by the scientific community, sorry to say, as kind of an excuse of saying that's just normal. It's just nothing special in there. It's nature. When people say, "Oh, it's natural," it's natural means there's nothing special here. So here, think about it. I want to reread this. If the situation were reversed, we would call the resurrection of bodies nature and the resurrection of seeds miracle. So we need to understand what's a miracle and what's not a miracle. So is there anything simpler than a seed? And I looked and I looked and I wanted to find something about the seed. And I found an amazing scientist out there who had a very, very 10-minute talk that I want to share with you. Some of you may have seen it, but I want to share it with you because then after that, I'm going to ask questions, we're going to do a written exam. No, just kidding, just kidding. Now, we're going to discuss, but just think about the model that this guy's amazing. I don't know, if you know him, let me know. Here we go. How do we do sound? There's no better way to do sound? Uh-oh. Okay, you can hear? So let's be very quiet now, and let's try to see if we can.
Does your remote control have the sound on?
No, I put the maximum sound on my computer, but I connected it to the.
Works.
Yeah.
To go down, and the trunk also will do a U-turn to go up. My name is Nessim. I am a professor and scientist at Bar Ilan University. I was born in Italy, and I went to French schools because from my mother's side, coming from Egypt, we spoke French at home. And then I went to study engineering at Politecnico di Milano, and I was fortunate to meet an entrepreneurial professor who sent me to France as the first experimental case of Erasmus program exchange program, where I went to Ecole Centrale Paris, I electrical engineering there, and graduated with a degree. I applied for a Ph.D. at MIT, and I was okay to be accepted at that Arnold's place, which basically is one of the top universities in science. I did my doctorate there, my Ph.D., and you can see in this picture a very moving moment where I have my daughters putting the hood on me. It's kind of a medieval tradition that they have in the States, this kind of scarf. When you graduate, and here I have my daughters putting it on me. From there, I joined the Bar Ilan University in the chemistry department, and that's where I am right now.
Were you religious your whole life? Observant?
Absolutely not. The school that I went, the French school I mentioned before, was a school run by French nuns. We didn't observe much at home, but we always believed in God. I remember my grandfather, who taught us some basics, and I remember going to the synagogue where I was going to Shabbat, but too much longer to really understand what Judaism was, which was only some 20 plus years ago when we moved to the States. That was the start.
Many people wonder if science contradicts Torah thought and the belief in God, yet here you are, a religious Jew, you're a scientist and a professor. How do you reconcile the two?
It's a funny question because when you realize how complex the world is, how complex all the phenomena are, how everything is synchronized in an amazing way for us to be here, to have this talk together, then you realize that all this requires a creator. The deeper I look into science and scientific points, the more I see the hand of God. When we see complexity, organization, like Rabbi Dormino used to say, plan and purpose, then it absolutely requires to be a creator.
Would you be able to share something specific with us?
Let's take an example really, really simple. A seed. A seed has, on one side, there is the root that comes out. On the other side, you have the trunk that comes out. Now, as far as I know, the farmers, when they plant the seeds, they don't pay attention to put them in the right orientation. They put the seeds on a random way, and when you look at how the seed behaves, the first thing he does is to put the root going down. How did the seed know about this? Imagine being the seed. You have a GPS, you have weights that tells you where down is. You are surrounded with earth, but the seed knows that if he has been put upside down, the root will do a U-turn to go down, and the trunk also will do a U-turn to go up. That's one of the things we should marvel about, and you can see from those images, time-lapse images, that you see exactly this depending on the rotation of the seed. You always see the root going down and the trunk going up. And then, what is the seed? I see the seed as a combination of three things. A supercomputer, an encyclopedic database, a humongous database, and a chemical factor. So let's understand this. So the seed is there. The program says, now put the root down, draw the root. So start from the root. Once the root is going down, it says, try to grow the branches of those roots, so to get more of the grip into the earth. Once it has some of the grip, it says, okay, now it's time to grow the trunk. So it starts growing the trunk. And of course, the materials of the root and the materials of the trunk are not necessarily the same. So the chemical factory has to say, okay, now supply some molecules for the root and now different molecules for the trunk. And the trunk starts going up. And you can see how strong the force is for lifting the earth and get out of the earth for this trunk. And this trunk starts going up and starts growing also in size. And eventually from green, it becomes more wood, which is different materials. So there should be the chemical factory somehow has to supply all these materials. At some point, the program of the supercomputer says, hey, hold on a second, now we have to start growing branches. So it needs to decide where to grow branches. And branches is not an easy thing because the purpose at the end is that all the leaves of the tree will maximize their exposure to sun. So the calculation of where the branches should be and the secondary branches and so on should be and where the leaves should grow. It's not easy. It should be a program that optimizes, maximizes the sun exposure. So now you have the program says, okay, grow the trunk, and then new program comes in, grow the branches. Third program comes in, grow the side branches, so the branches on the branches. And eventually says, okay, now grow the leaves. Hold on a second. The leaves are green. The wood is brown. They're different material. In fact, the leaves is a very complex system where you know about photosynthesis, one of the most efficient chemical conversions that convert basically the sun and produce oxygen and carbon dioxide at night. And all the leaves should be positioned in a way that they don't obstruct the sun from the other leaf. So you need to maximize sun exposure. You see, it was not green. The earth is not green. Water is not green. Air, oxygen is not green. Where is the green coming from? So somehow in there should be a production of something that is green. And then the program continues, a new program kicks in and says, now we need to grow the flowers. So now the flowers, some are white, some are yellow, some are pink. Where are those colors coming from? Same discussion as before. And then once the flower grows at some point, a new program kicks in and says, now, fruit. You want the fruit in there. So you start deciding, you first decide where are you going to grow the fruit on the tree. And again, you have to make sure that the fruits are not kind of colliding one with each other. So they should be in specific positions to maximize the dispersion of those fruits on the branches. And when the fruit grows, there's something I want you to think that is absolutely fascinating to me. Is, let's say, an orange. An orange is kind of a round fruit. And when you have a round, let's say, sphere, you have a volume, and you know the volume goes with the cube of the radius. And the surface, the peel, goes with the square of the radius. So one goes with the cube, one goes with the square. From the same stem that gives the nourishment for the orange to grow, it needs to calculate exactly how much you put inside and how much you put outside. And there are different rates. One is a cube of the radius, one is a square of the radius. So everything should be calculated precisely. If it's not calculated precisely, either you have a peel that is flapping around outside, or you have a peel that breaks because it stretches too much because the inside grows too fast. So the two growth should be synchronized. Fascinating problem. And then the orange is green in the beginning. What is this green? Green grows with the leaves. It kind of sends you the message, hold on a second, don't pick me up yet. I'm not ready, I'm not tasty yet. At maturity, it changes color. Becomes orange. From green to orange means there's chemical development here that happens to change the color, right? And when it's orange, instead of saying, hey, come, pick me up, I'm ready, pick me up. And then you see that the peel is amazing. The peel protects from the rain, from the elements. It has even antibacterial properties, kind of repels the insects. And it has even a nice smell when you squeeze the orange peel. It has kind of that nice thing. And when you want to open the peel, you see that inside it's white. Well, I said, well, why is it white? Because you don't need the color once you open it. You don't even want to eat it. And I think it's interesting, it's the stem itself. The stem is very strong and it supports the fruit. At some point, when it gets to maturity, the stem kind of becomes weak in a way that it becomes so weak that eventually the fruit can fall down. Or you can pick it up. Synchronized exactly. So when you think about it, it's amazing. You have here a supercomputer, a huge database of information with this program that needs to know when to grow the roots, the trunk, the branches, the secondary branches, the leaves, the flowers, the fruits. Synchronized with all this with the chemical factory that has to deliver different molecules for the root, for the trunk, for the leaves, for the flower, for the inside of the arch, for the outside of the arch. And all this is in there, in that seed.
These are the type of questions that they're fundamental, but people rarely ask.
Yes, because we take things for granted. You know, the plant you see, you get an orange and it's obvious. We call it in Hebrew area. Why use wood? So we rarely ask such kind of questions. Interestingly enough, Rashi says that who is someone intelligent? It's not someone who may think, oh, someone knows a lot, encyclopedic knowledge. No. Rashi says, an intelligent person is shohet derech chokmah, someone who asks intelligent questions. So the purpose here is for us to ask intelligent questions. And a question like, for example, how do we go from seed to orange? That's a good question. And by the way, I want to tell you, on this cycle, I told you quite a few things. We have a lot of questions. We may not have all the answers, but at least we have good questions.
So this amazing video that Aaron Ovadia put together can be found on Drops of Light. And as I said before, it is also on other sites like aish.com, chabad.org, and we are trying to put it, well, I'll talk to you later about this. Anyway, so let's just summarize the model that we need. The model that the scientists said was we have a seed, which is a supercomputer, plus gigantic program, plus chemical factory. Those are the three elements of this seed, right? That was his model. The question is it a good model? Is it? It looked quite impressive, right? But does it say the truth? Is it a complete model? And is it always valid? So we need to question those things. And in fact, let's ask a general question. Is science always true? There are people who worship scientists. When the scientists talk, wow, وَنَحْنُ مِشْتَخَوِيمْ على words of the scientist said, right? Is it always true? If you go on the web and you look on Wikipedia, list of scientific misconduct incidents, it's something like 6, 7, 10 pages list of names and things that happened in there. One of my favorite, this one. This guy is a super smart guy, Jan Hendrik Schön. What he did, he was working on a super duper research of a single organic molecule for semiconductor, for transistors. So if that research would have worked, today the computers would be gazillion times much better than we have today. Amazing research. Imagine having one molecule that can be the bit of information. So he published papers, and his papers started going one after the other. Science, Nature, Science, Nature, Science, Nature. I don't know if you know what it means to publish in Science. If you are a scientist, you know it's nearly, I'm still praying to publish something in Science or Nature. This guy ended up with something like 20 papers between Science and Nature, one after the other, and also in other journals. So when he was publishing on journals that I would be happy to publish, for him it was just the reject of his work. But after a few years, you know, when you have such a top-level research, there are other people who are trying to continue your research and you expand your research. So there were students that started working on this problem. And they started looking at his paper and trying to replicate his experiments. And they did not work. And they tried and it did not work. And they tried and it did not work. And there were students that ruined their Ph.D. because they tried to do this. And at some point, they started having suspects. Something is fishy here. So they started looking very, very carefully, and they figured out that there were two papers that had the same level of noise. Noise is a random signal. Impossible to have the same noise 2 times, exactly the same. So he was faking up the results. They figured out, they stripped his PhD, then it went to another code, gave it back, and they took it out. I mean, you need to be smart to put up a fraud like this, right? Really, really smart, but it's chaval. Right? And this some called it one of the biggest scandal in science, at least in recent times. Something like almost 30 articles had to be retracted from the scientific journals. Huge scandal, okay? Another one that is a different type of scandal is, you probably heard about Watson and Crick. They discovered the DNA. Well, they stole the data from Rosalind Franklin. She's the one who showed them the microscopy image of the DNA and stuff, and she's never mentioned. She never got the PhD, the Nobel Prize that they got, etc. They got the whole thing, and everybody knows the fraud that they did behind the scene. So we need to be careful about fake science, right? So, like, you know, there's someone that we all know that says there are fake news. There's also fake science. So be very careful, you know. And especially there are some fields of science that are, in fact, you know, I'll tell you one thing. When I started my PhD, there was an Indian student who finished his, and he kind of mentored me a little bit. And he said to me, listen, more than half of the paper just say lies. I couldn't believe it. I came from industry. I was fed up of the politics in industry, and I wanted to go in a clean, tahor environment. So I went to university, right? So to do a doctorate. And the first thing he says, you know, it's a bunch of lies up there. Okay, so that's one of the things we need to be careful of that video that we saw, did he say the truth? But the second thing we need to be careful with scientists is the following. For example, Newtonian mechanics, if some of you like this is nice equations here. But anyway, so Newtonian mechanics, meaning the classical mechanics, is a fantastic theory. With the Newtonian mechanics, we build buildings, cars, airplanes, everything you see around that you use in your normal daily life is done with Newtonian mechanics. You know, they designed the shell of this thing so it doesn't break if I drop it and so on. Newtonian mechanics. Everything Newtonian mechanics. So, but the question is it always true? It seems to work, but what if something goes very fast or something is very small? So this is Newtonian mechanic called classical mechanics. If we go to the level of atomic or subatomic particles, or at the nanometer level, we entered quantum mechanics. Quantum mechanics is a completely different beast. If any of you has any knowledge of it, you know it's ununderstandable. In fact, Richard Feynman said if someone says he understands quantum mechanics, it means he doesn't understand it. Because nobody understands quantum mechanics. And there were these famous discussions between Einstein didn't like it. Einstein was one of the inventors of quantum mechanics and he didn't like it. And he had a discussion with Niels Bohr, who was another of the big discoverers of quantum mechanics. And he said to Bohr, because quantum mechanics, you know, Newtonian mechanics says, if I drop this, I can calculate exactly what these things will be every second and what is going to happen. But in quantum, you cannot. There are probabilities. The electron can be delocalized somewhere. There's a nice joke that I said to my students is, only anybody knows a little bit about quantum mechanics that can say a joke or not?
Say it, try it.
Okay, the joke is the following. Werner Heisenberg is the one who postulated the uncertainty principle. You cannot know where the electron is and its momentum, let's say its speed. You cannot know how fast it's going and where it is at the same time. Either you know where he is or how fast he's going, or you have probability of where he could be and how fast he's kind of going within a range, right? So Heisenberg is driving on the Autobahn in Germany. He's a very German scientist, and he's driving too fast. And the policeman stops him and says, Professor Heisenberg, do you know how fast you're driving? He looks at the cop and he says, no, but I know where I am. I don't know how fast I'm going, but I know where I am. So this is quantum mechanics. It's for me, I'll tell you one thing that is my thing, but for me it's kind of saying, Hashem said, ad kan. You can know everything at can. More than, no, this you can't. Impossible equations, probabilities, distribution, orbitals, psi functions, and all kinds of wave functions, crazy things. This is if we go too small. If you go too fast, relativistic mechanics, relativity. If you go close to the speed of light, then things time change, distance change, and so on. So classical doesn't work anymore. And of course, if you combine something small that goes fast, even worse, quantum field theory, right? So when you put everything together, you need to know the classical mechanics works if you are bigger than a nanometer, and you are much smaller than the speed of light, which is 300,000 kilometers per second. So does it mean the classical mechanics is to put in the garbage? No. We just put a boundary, and you say it works only with this condition. So when you see a theory or a postulate or anything, you need to know, first of all, is it true? And second, if it is even true, does it work always, or there are some restrictions in there? Okay. So Newtonian mechanics was correct, but incomplete, because it applies only for size way above nanometers and speed way below the speed of light. 300,000 kilometers, this is a mistake, 300,000 kilometers per second. Okay. When I was in Italy, at some point among the many hobbies, when I was a teenager, you know, Baruch Hashem, there's no teenagers here, almost. Okay, anyway, at some point I had the hobby of planting seeds. So, and there's a place called Ingegnoli, it was a store in Milan, who was selling seeds. And you go, and he has this huge inventory of different bags with the seeds, and he has a nice picture on top of what kind of vegetables or flower you're going to get from this seed. And you have this bag, paper bag, which inside something like 20 seeds or something. Like it's like you have 20 little tiny marbles, millimeter size. And you buy those, but hold on a second. What happens if I leave them in the envelope? You know, at the end, as any hobby that I had, they remained in the envelope. And I don't think they ever grew. So they remained in the envelope. So nothing happens. So no supercomputer, no program, no chemical factory. It's like a dead object. So what is the guy saying before, right? So it's like nothing. So that means we need to plant the seed in the earth. So now we need to revise the model. Let's revise the model 1 second. In fact, before we revise the model, for how long do you think we can keep the seeds before planting them? Any guess?
2,000 years.
Oh, great. You are fast. So there was an amazing thing. They found some seeds of dates in Masada, in kind of a jar or something, that when there was the Masada thing, they found those seeds, and then they stored them in the lab for 40 years after that. And then someone had the crazy idea of saying, what if we plant them? Isn't there a way to grow and see what a date of 2,000 years ago, of the time of the Gemara, tastes today? And they tried, and the first time they tried, it came out, I didn't know this, but believe it or not, there are male seeds and female seeds, okay? And in the seeds, I can guarantee you, at least maybe they will invent it in America, there's no all those flavors that transgender and trans this and LBGT and everything. There's only male and female, okay? There's only male and female. So what's the difference is the female seed, I think, which one is it? One of them gives the fruits and one doesn't. So the first one they tried was the wrong type. So it didn't give fruits. And they did the second time, and it gave fruits. And they could taste. I would love to taste what a date of 2,000 years tastes, right? It may be the same as today, but anyway. It's amazing, 2,000 years. So bottom line, the seed is a dead thing for 2,000 years, and then suddenly sprouts to life. It's like, do you know anything that resists 2,000 years? I mean, those chairs would not be here in 2,000 years, right? Another thing I want to show you. This guy, Eric Drexler, did his PhD at MIT, and he wrote his thesis, and he wrote a book that was very famous that somehow popularizes nanotechnology. It's called Engines of Creation. And he wrote a book, and it's a very nice book. And he said something that, okay, I hope you didn't eat recently, right? So, okay. So he said, imagine a microwave-like machine where you put inside cow's dung, and after rearranging all the molecules, you get a nice hot steak. Well, it's not exactly his words. I paraphrased his book. But why? Because the cow's dung has the same molecules, same atoms as a steak. In fact, think about this. I want to tell you one thing. Ladies usually, I was told that ladies like diamond. I don't know if it's true or not. It's a rumor, right? So, diamond. I love pizza. And pizza in Italy, you know how you do? You have ovens where you put those black carbons in there, right? I have news for you. The diamond and the carbon of the pizza is exactly the same atoms. It's called carbon. It's a carbon atom. One is transparent, one is black. One is the hardest material on earth, one is super soft. One is a super insulator, one is an amazing conductor. One is super expensive, the other one is ultra cheap. They are the same atoms. What changes? The way they are rearranged. So the way you rearrange the atoms, you can have two materials as different as diamond and carbon, right? By the way, to console the ladies, I want to say something that will scare the ladies and then will console the ladies. In thermodynamics, we say the most stable form is really the carbon of the pizza. So meaning you have always a chance to go to sleep and next day to wake up and, my diamond ring is now carbon, right? Pizza carbon, right? But you are lucky that it doesn't happen because kinetically it has a high activation energy and it's not going to happen. So don't worry. I want just that you are relaxed. So, and the question is, isn't that what our seed does? This vision of the microwave-like thing that you put the dung and you get the steak out, isn't that what the seed does? Look at the seed. The seed uses the soil and its nutrients and transforms them to create all the molecules needed for the root, the trunk, the branches, the leaves, the flowers, the fruits. And by the way, what's the best nutrient? Cow's excrement, right? That's exactly the best thing they like. That eventually becomes an orange. Sorry. Okay, I hope you still like oranges after that talk. So anyway, so it's just things are arranged. So you see them, I want you to understand what the seed is doing. The seed, first of all, does nothing when it's on the envelope. When you put it in the earth, it starts taking molecules and rearranging them doing the machine that Eric Drexler wanted to do, rearranging them and start forming the roots and the trunk and the leaves and the fruits and this thing, and you get an orange. It's amazing. It's amazing. So let's revise the model. It's a seed as a supercomputer plus gigantic program plus chemical factory, and it needs an earth, right? So at least we revise the model. In Chassidut, by the way, the seed is male and the earth is female, right? Not to confuse with the male and female type of seeds. Is the model now complete? Chevre, is it complete? No. What's missing here? Water. Water, okay, then? Sunshine. Then? Huh? Air. So, of course not. We need water, H2O. We need air. Air, by the way, is 21% oxygen. We're going to talk about that in a second. We need sunlight. So let's see one at a time. Let's see water first. The miracle of water.
Carbon dioxide.
Yeah. Let's see water first. 70% of the earth is water. 70% of our body is water. Be'erech. Right? Amazing. And by the way, the water doesn't leak. Okay? I have a problem with a neighbor who has a leak above me, but I don't leak. Okay. So best solvent, it's the best solvent to dissolve minerals without destroying them. So the water is as the minerals inside without dissolving them. Right? It has low viscosity. If it had higher viscosity, it would have a lot of other problems. Evaporative cooling to stabilize earth and body temperature. You know, why do you sweat when you start running and so on? Because that's the way to cool your body. Your body heats too much, and by releasing the water, it starts cooling it down. This is an amazing thing. There's something like, to my knowledge, something like 6 or 7 things there where the density of the solid state is lower than the density of the liquid state, meaning that the solid floats on the liquid. One of them is ice, as we know. The other one is silicon, which, by the way, if that didn't happen, we wouldn't have computers, cell phone, and everything like this. Maybe it would have been better for humanity, but that's not the case. Okay? Germanium is another one, etc. But there are 5 or 6. All the other materials, iron, copper, everything else, the solid sinks in the liquid. But water, no. Think about the miracle. Avigdor Miller says, if it did sink, it would kill all the fish the first time it freezes, and it's game over for life. Right? But what happens? It forms this ice on the surface that floats, that insulates thermally to protect from further cold the water below, and the fish are happy there. Amazing. So the fish can continue swimming happily after the surface of the river freezes in cold weather. And among the many miracles of waters, it is present only on our planet. You know, every time they want to investigate for foreign planets and foreign life, Avigdor Miller says they're spending billions of dollars just to prove there's no creator that can find life somewhere, and they were not going to find. And by the way, the first thing they look for is water, and they can't find it because we have it. So now I want to show you one thing on water that is very technical. Please hang on, okay? Fasten your seat belts and try to follow. So this is boiling temperature. And this is on the periodic table. You have oxygen, sulfur, selenium, tellurium. Usually elements on the same column present the same kind of properties. Be'erech. When you go down, they become bigger atoms, but they basically have a similar kind of external electronic structure, meaning they behave more or less the same. So if I have H2 with tellurium, 2 hydrogen and 1 tellurium, I have a boiling point of something like close to 0 or a little below. Okay? If I put selenium, which is a little lighter atom, so I have a melting temperature that is something like minus 40 degrees because the atom is smaller, the bonds are stronger. So it's, so anyway, or the opposite, whatever. So if I do go to sulfur, I find that it is minus 60. So if I find oxygen, H2O, 2 hydrogen, 1 oxygen, I should find something like minus 80 degrees. Isn't that the trend? This is the trend. But magically enough, you look at your chemistry book and you say there's something called hydrogen bond. Hydrogen bond happens with something like 3 or sometimes they say 4 different atoms that are have high electronegativity, and therefore, bam, it bumps to plus 100 degrees Celsius. And thanks to this, we're here having this talk. Because if water had a boiling point of minus 80, there wouldn't be no talk tonight. Okay, there would be nothing. We wouldn't be here. And we are here because of this hydrogen bond, because the electronegativity of oxygen is so high that it makes this special thing that you see it's out of the norm. It should not have been like this. It makes you think, right? Wow, Hashem, thank you for the hydrogen bond, okay? And another thing on the water, it's amazing because it's a whole recycle. By the way, we may drink the waters that Avraham Avinu drank, or maybe Esav, I don't know. The bottom line, you have water evaporates, then you have wind, you have condensation, meaning it condenses into clouds, and then you have winds that bring the clouds where the water is needed, and then it rains, and then through the ground it goes back on the oceans, the river, and the cycle continues. It's a pretty amazing thing. It's a pretty amazing thing. And and Rav Victor Miller says how amazing it is that the winds, that by the way are very difficult to predict from a weather forecast and stuff like that, are the ones that makes the rain where it should be, right? Because if it just evaporated and condensated and then refell back at the same place, it would not be so useful, right? Why we have water? Because it goes from the sea, the ocean, and then it comes to us. The miracle of air. Perfect cocktail of gases necessary for life, like Rav Victor Miller says. Oxygen is necessary for energy and complex life. Without oxygen, there's no life. And oxygen is not flammable, but you know, if you have too much oxygen, things burn more rapidly and more easily. And so it's dangerous to have too much oxygen. In fact, a lot of fires are in the hospitals when they have rooms with a lot of oxygen. And I want to show you something amazing. There is something like flammability limit is 23.5% in volume of oxygen, meaning if air had 23.5% of oxygen, things would burn much more, would be very dangerous, Hashem made it that we have 21%. So we have the maximum we can get without getting in danger zone. It's just nice coincidence, right, that we have 21%. And what would happen if we didn't have an atmosphere? You know what would happen? This. You know this guy here? It's called the moon. Do you know why the moon has all the craters here? Because it doesn't have an atmosphere. And all the asteroids and all kinds of things floating in space go and hit and make a bunch of poke holes in there. So we don't have this. By the way, it's very difficult to penetrate the atmosphere. A lot of things, by the way, burn in the atmosphere. In fact, one of the problems of the Challenger, for example, was to design the shell so that at its re-entry it would not melt. So you cannot have a metal. It was aluminum oxide, which has a very high melting temperature. So basically, moon has been bombarded by comets, asteroids, chunks, and all kinds of things. And that's why he has this kind of shape. And we don't want this shape. So Hashem made that we have an atmosphere. And the atmosphere is amazing because which frequencies come in the atmosphere? Mostly the visible, which are necessary for life, for plants, for photosynthesis, for everything. But for example, the ultraviolet are cut down. We don't want ultraviolet because they're very, very dangerous, right? So, and in fact, now we talk about the ozone layer and things like this because we have done damage to this, and somehow we have poked some holes in this shield that was our atmosphere, and we start paying consequence. We talk about lo alenu, skin cancers and stuff like that. And Michael Denton, beautiful books he writes, I haven't read, but he has beautiful videos on the web. He says the sun is a giant fusion bomb. You should have thermonuclear explosions going on the sun. And I want to show you one thing. This is our universe. Nice picture, huh? And here is the sun, and here's the earth, and we are something 150 million kilometers away, roughly. Okay, I'm rounding the numbers to make it easy to remember. And the earth has a surface that is at, let's say, 5,700 degrees Celsius. I would say it's hot, right? So you have this giant ball, super, super hot, 150 million kilometers away to heat our planet. It's an interesting design, huh? Isn't it? Well, you want to heat. You know, it's like saying, I want to heat the shul, so I'm going to put a thermonuclear reactor in Jerusalem, right? It's a strange design. And by the way, so it's intense radiative sun heat coupled with the Earth atmosphere. And the Earth atmosphere, look at this picture. You see this little yellow thing? The atmosphere is something like 100 kilometers in thickness, and the radius of the Earth is 6,400 kilometers. So it's 1/64th of the radius. So it's close to nothing. It's like an orange with this very thin peel, and that's the atmosphere, right? And thanks to this atmosphere, we get the temperatures we get. And in fact, if you look, Mercury, it's too hot. We cannot be there over 400 degrees Celsius. Venus is surprisingly even hotter because it has a very dense atmosphere. It has an atmosphere, but an atmosphere of 96% of CO2. So I'm not sure we would like it too much, right? And then you have others don't have atmosphere and they become super cold. So it's a great coincidence. We're exactly in the right spot with the right atmosphere for having the right temperature for us to be here to give the talk. Otherwise, it wouldn't work. And then, of course, photosynthesis. Photosynthesis is the process by which plants use sunlight, water, and carbon dioxide to create oxygen and energy in the form of sugar. So it's an amazing reaction that is going on like this. By the way, I remember at MIT, one of the researchers that we were doing was to try to duplicate synthetically this process. And of course we can't. But I want to tell you another thing. It's a completely, what nature, the nature, right? The nature. Fireflies. When I was in Boston, I remember when the Seudat Shishit, Shalosh Sudos, and then outside there were a bunch of fireflies. Fireflies are amazing. They have amazing light. I saw a thesis on fireflies. It's so complicated. The chemistry is so complicated for the fireflies, and it's one of the most efficient lights that you can imagine. Today we have LEDs, right? Fireflies is much more efficient, right? Just derech hagav. Okay, so let's revise the model. The seed is a supercomputer plus gigantic program plus chemical factory. It needs the earth, needs the air, needs the water, needs the sunlight. Is the model true and complete? Is it? Huh? Let me ask a question. What if we cut a piece of root or a branch and we replant it somewhere else? And how about the seeds that grow inside the fruits and we plant them somewhere else? You would have another one, right? So it's not one computer. By the way, the seed decomposes. Where's the computer? Where's the computer? It's gone. Well, where's the chemical factory? Who makes the decision here? I want to talk to the boss, right? I want the boss. Where's the boss? Right? So here, we revise the model one more time. I don't know if this is the right word, but this is what I put it. Proliferating network of supercomputers plus gigantic programs plus chemical factories. And it needs earth needs the air, needs the water, needs the sunlight. Is the model true and complete? So I'm going to leave it to you as a homework, because every professor has to give homeworks. So you have a homework now to think if this is complete. I want to give you a hint. Think DNA, okay? And that's maybe for another time, because DNA is another parsha. So we're closing here, and I want to say one thing. Why I do this? My mission is, I'm not a Talmid Chacham, but I've spent instead of, I think, like one rabbi told me, do you think that, I think HaKadosh Baruch Hu, the secretary of HaKadosh Baruch Hu made a mistake. I should have gone to the Mir Yeshiva. But instead of writing Mir, she wrote MIT. So I went to MIT instead of the Mir. So I think that was the mistake. So I'm trying to kind of correct and do what I can. So I think, but with what I learned, maybe it can help people to see the creator in science and nature like we have tried to do today. And I will do something that is very atypical. I've never done it before. I'm totally useless at this. Believe it or not, I have an MBA. But in terms of business, I'm the worst that you can. Don't ask me anything about stocks, because I only lost money on stocks, never gained money. In fact, when I gain money, I continue staying there until I lost money. So I have done a lot of those videos that you saw in French for a site called Torah Box, which is the Torah Anytime, the French Torah Anytime. And there are something in there like something like 17, I think, videos right now on the human body, like the ears, the eyes, the nose, teeth, and feet. Well, some on nanotechnology and science and truth and chemistry. There are some on the seed. There are some on animals. And some with some interesting thoughts, deep thoughts about scientific things. And they have been very popular. In fact, between the different channels that they have been viewed over 1 million times so far. And I mentioned that to Aaron, and we wanted to do the same thing for the English-speaking public. And we did one video that you saw before. And this video, in fact, there are two versions. We showed you the long version. There's a shorter version of it. And it went, of course, on Drops of Light, in Hamad.org, ish.com. And Torah Anytime wants them. But they said, we want a series. And the problem is to do a series, one thing that costs money is the video editing. So we found the video editor, but we need the money. So we need sponsors. If any of you is interested or knows people, dedicate a video Leinu Nishmat someone or for whichever opportunity or something. If you want to join the mission that we have to try to spread this message, let me know. If you know French, please do go to Torah Box, type my name in there, and you'll see a lot of very, very interesting video with amazing video editing. You'll see how nice it is. It gives a completely different flavor when you have the nice video editing. So, of course, what is the key message that we have to understand when we see what we saw? That there is plan and purpose, like Rabbi Victor Miller says. There is plan and purpose in every aspect of recreation. And I want to put back the quote that I put before of Rav Sitruk. Nature is the modest veil of protection that God extends over man so as not to force him to believe in God. And we said before, Rav Dessler said, if we were used to see a resurrection of man but not of seed, we would call the first one nature and the second one miracle, right? And now that you have seen what you have seen, read this sentence again and think about it. You realize how amazing it is, right? So we plant a seed and we think it's obvious. Now, you don't think it's obvious because we have spent an hour together trying to understand how not obvious it is. But it's Hashem has given us a way that we can not believe in Him, right? It's pretty amazing. So this was basically to show you, thank you Hashem for this amazing, amazing world. And now, like Rabbi Yunus said, he says, questions on any subject. But I put a proviso that with no guarantee that I can answer the questions. And this is an email I just developed now for this. If you have any question, topic, interest in sponsorship, whatever it is, science613miracles@gmail.com. Isn't that nice? Science, I tried science 613 was taken. 613 science was taken. So science613miracles@gmail.com. Thank you for all the ones that were on the YouTube Live. Now we're going to cut the connection of the YouTube Live and we're going to go for the questions. So if there are any questions,